Thermal Resource Group LLC is an Arizona-based designer and manufacturer of the Thermalicity electrical power systems. The efficient two-stage hydraulic engine utilizes low-grade heat as low as 180 degrees Fahrenheit to produce electrical power, where other systems require high temperatures and high pressures to produce power. The ability to utilize low-grade heat sources brings TRG's Thermalicity engine into the realm of power production where no other technology is able to go. Heat resources which were once discarded as waste are now sources of energy and new revenue. Whether the source is low-grade geothermal, solar heat from parabolic troughs, solar ponds, biomass, or landfill gas, the Thermalicity engine provides clean, renewable power. This cost-effective approach captures, produces, and distributes power for in-house systems or for grid intertie. Waste heat from existing steam turbine power plants and manufacturing operations, such as heat treating operations, foundries, stack heat, and food process operations, are now economically viable sources for power production. Thermalicity's power plant capacities range from 250 kilowatts to 1 megawatt. Although the Thermalicity system thrives in lower heat applications, by integrating new developments from heat recovery system manufacturers, we are now able to utilize high heat sources from geothermal wells where pressures are 700 psi or higher and water temperatures are in excess of 575 degrees Fahrenheit. Unlike conventional geothermal power plants, where 60% of the energy is lost due to phase conversion of water from liquid to steam, with the resulting water problems and high operating costs caused by that phase change. Thermalicity is able to take advantage of the full heat source and use all of the BTUs from that high temperature water. Thermalicity can produce 2 to 3 times the amount of power from the equivalent geothermal well flow at a fraction of typical operating costs. Conventional coal, fuel oil, and natural gas steam turbine power plants use a considerable amount of water to condense their steam and reclaim their condensate. Thermalicity can take that same steam heat, condense it, produce additional power, and also accomplish the recovery of that condensate. Consequently, a conventional power plant could almost double its power production. How is this accomplished? This is a diagram of the Thermalicity technology, specifying heat recapture, cooling system, heat exchange, a process heat exchanger with a working fluid such as liquid CO2, the triplex cylinder assemblies, which pressurize the hydraulic oil system, and the hydraulic motor and generating equipment. A heat source is captured in 2 ways. First, if the heat source is an airstream or steam, the heat is captured by circulating water through an economizer or heat exchanger. This captures the heat and transfers it into a fluid, such as water or a thermal oil. The heat from the fluid is then circulated through a second heat exchanger, which heats the closed-loop water system on the Thermalicity engine. This closed-loop hot water at 180 degrees Fahrenheit is circulated around specifically designed shell and tube heat exchangers, which contain a working fluid. When heated, this working fluid expands and drives a piston within a cylinder assembly in one direction, which in turn pressurizes a flow of hydraulic oil to 5,000 psi. On the opposite side of the cylinder assembly is a second process heat exchanger, which is concurrently being cooled using a closed-loop cooling tower system. This causes its working fluid to contract and move back into the cooling heat exchanger. At a specific time, a series of control valves change direction, and the heat exchanger, which was previously being heated, is now being cooled, and the previous heat exchanger being cooled is now being heated. This causes the triplex compounding cylinder assemblies to move back and forth to produce a laminar flow of hydraulic oil, which proceeds to a hydraulic motor. The hydraulic motor causes a generator to rotate at 1800 revolutions per minute, producing 480-volt three-phase power. A second option is to take a hot liquid, such as geothermal water, and extract the heat from it into the closed-loop hot water system previously described. From then on, the entire process is identical to the discussion. Thermalicity is power production that is clean